Assalamualaikum and hello everyone. So before that, my name is Muhammad Haikal bin Abu Bakar, and these are my group members. So our group has choose Pilajak Kure for Group F as our group assignment, and today I will be talking about for the question A and question B. So let's proceed to the next slide. And for the question A, it was given to describe and summarize the sample data of the assigned Lajak Laku tablet that was produced in December 2020. So we will proceed to the reference of question A, which is appendix 2. As you can see, the tablet is categorized into morning, evening, and night. From the data given, we can calculate the sum, mean, and the standard deviation of weight, relative density, and tensile strength for every shift. So for the figure 2.0, we can see the value of sum for morning shift is slightly higher than evening and night shift. So from the figure 2.1, we can see that the value of mean for every category is slightly different, which is mean for morning is quite higher than the value of mean for evening and night. The next one is for figure 2.2. We can conclude that the standard deviation for morning also slightly higher than the other shift. Last but not least, for figure 2.3, we can determine the consistence of the production from the value of mean, and also we can detect the changes in defect the product by using the standard deviation. By this, it will help the company to overcome the defects in the easiest way. So for the next question which is question B. The next one is question B, and to comment whether there is significant evidence that larger Laku tablets that produce in 2020 regardless of shift do follow this distribution. So we are using Microsoft Excel to create a frequency table. Then a hypothesis test is conducted at alpha 0.05 significance level. So for the step 1, as you can see, there's a H node, and the X follow the normal distribution at 315 for the square. For the H1, X stated that X does not follow normal distribution at 350 for the square. For the step 2, statistic test. The next one, step 3, they reject the H node if X squared test is larger than X squared 0.056, which is equal to 12.5916. So since X squared test is less than X squared at 0.56, therefore we fail to reject H node at 5% significance level. For the last step, the conclusion. So we concluded that the weight of standard tablets produced by manufacturers is normally distributed. So we'll refer on appendix 3. So before that, we refer to table 3.0 frequency table. We can see that the expected frequency for first and second range does not meet the expectations that greater than 5. Okay, so since the expected frequency needs to be greater than 5, which is EI is greater equal than 5, we decided to combine the first and second and third range so that the value of EI does not less than 5. The reason why we combine the first three is because we combine the first and second range only. The value of EI still not greater than 5. When combine the range, there are different occurred in degree of freedom. From k equal to 9, it becomes k equal to 7. Therefore, the degree of freedom is equal to 6. Okay. From the hypothesis test, which is a chi-square test, we can conclude that there is significant evidence that the larger Laku tablets produced in 2020 follow this distribution. So I will proceed to the next question C for Abra, which is my friend. Thank you.
Assalamualaikum. So for the question C, comment on whether there is any significant difference between tablet weight from the different shifts. By using macroapp cell, a pivot table is created as appendix 4. So from appendix 4, we can see that here overall a pivot table based on shift, we divided into evening, morning and night, and then we find the value sum for each and mean also, and here we got for overall pivot table. And then we conduct a hypothesis test using alpha is 0.05 significance level. So for the step 1, we are using h naught is equal to mean 1, equal to mean 2 and equal to mean 3, while for h1 mu1 is not equal to mu2, mu j, mu I is not equal to mu j for at least one inequality. In step 2, we are using ANOVA data analysis that we are construct in appendix 4, which is called pivot table. So let's see pivot table here, and here this is ANOVA. Sorry, pivot table is here, and then we create ANOVA data. So this is ANOVA data. Okay. For the ANOVA data, we have sum of square, which is value is between group is 50.4994, and we also have degree of freedom, which is 2 for between groups, and also we have mean of square. And finally, we calculate for f, which is f calculate is mean of square for between groups if divided within groups, which is 35.34997 is divided to 217.4887, and we got for f calculate is 0.116098. And we also calculate for f crit. We also got value 3.041753, and the last one we also got for p value is 0.8904449, and this is ANOVA table. And step 3, we have to reject h naught if f calculate is greater than f crit. So when we see the table before, we notice that f calculate is 0.116098, which is less than f crit 3.041753, and because of this we have to fail to reject h naught, which is we accept the h naught at 5% significant level. So for the conclusion, there is no significant difference between table weight from different shift at 5% significant level. And for the whole step that we have done from table 4.1, we can see for all the shift have different counts, average and variance. Therefore, a hypothesis test is important in order to see whether the means are equal or not. A one-way ANOVA test is conducted to check this one. There are two ways actually to interpret the output for the ANOVA table from table 4.3. Let's say 4.3. 4.3. Oh, sorry. I'm sorry, so sorry. I give 4.3 here. And then and there are the other one is as we do above, we have to see p-value, and we have to compare with the f-crit. If it's less than f-crit, therefore we have to reject the h-node. So in a nutshell, we can say there is a significant difference between table weight from different shift at 5% significant level. Okay, thank you. So for the question D, tablet's hardness can be represented by its relative density and tensile strength. Study has indicated that its tensile strength depends on the relative density. Regardless of production shift, recently a batch was found to produce cluster of tablets that show low relative density value of 68%, 74.3%, and 80.1%. Based on the current data in January 2020, what is the prediction of the tensile strength for such tablets? Comment on the validity of the model that you have used to carry out this prediction. So, a target-fitted linear regression equation is obtained referring to the output coefficient in table 5.2. So, to produce linear regression equation is y equal to alpha plus beta x. So, how do we get the value alpha and beta? So, from the table 5.2 here, in predict tensile strength 5.3 is here the table relative density 68, 74.3, and 80.1. And also we have the value 5.5, 6.0, and 6.5. So we have to point out the important value, which is n to 100, summation of xi, summation of si square, also summation of yi, and also summation of y square, and so on. So to find the value alpha and beta, first we have to find the value for beta, which is the formula is SXY over SXX. So how to find SXY is summation xi times by yi minus 1 over n and multiply with summation xi times by summation of yi, which is we will get 68.71665. And for the xxx is summation of x power of square minus 1 over n times by summation xi in bracket power of 2, which is I get 878.56755. So divide two value, we will get value of beta, which is 0.0782144. And we substitute in this equation, we automatically find the value of alpha, which is 0.261687. Hence, the linear regression equation calculated is y is 0.261687 plus 0.0782144x, and tensile strength can be predicted correspond to relative density given. And then after we obtain the linear regression equation, hence the value of tensile strength can be predicted based on simple linear regression equation obtained correspond to relative density. In order to validate significances of the linear regression model compute, several tests can be executed on the linearity of the regression. And the one and only is hypothesis testing, which is H-node we use beta equal to 0, while H1 beta not equal to 0. So in referring table 5.1, okay, 5.1 here, table 5.1, which is ANOVA table, F value is calculated by SS, which is summation of square, and DF, which is degree of freedom, and for regression, residual, and also we have to find the total. In order to make decision on the significance of the regression, significant F is compared to chosen significance level. So the significant F is a probability of F value is larger than the test statistic, which is PF is greater than 493.28736, which is equal to 1.173 power of negative 55. If chosen significant level alpha is equal to 0.01, is higher than the value of significant F, thus H0 is rejected. Yes, H0 is rejected, concluding that there is evidence of the relationship between relative density and tensile strength do have linearity. And that's the method of using by ANOVA method. There is also another method instead of ANOVA, which is we call a t-test. By referring table 5.2, okay, let's refer 5.2 here, this one. And t-stat is 2.2 at 22.210073 for beta, and p-value is computed is a probability of t-stat value larger than the test statistic, which is p-t-stat is greater than 22.210073 and the value is 1.173 power of negative 55. So result from the probability is much lower than the chosen significant level 0.01, indicating that beta is not equal to 0 at 1% significant level or 0.01. So hence we have to H0 is rejected. The test results support an evidence of linearity relationship does exist between tensile strength and relative density. Chosen significance level at 1% are so small, indicating a strong evidence is rejecting null hypothesis. Moreover, correlation coefficient value multiple are equal to 0.8447354 implies that there is a strong positive linear relationship between independent and dependent variable sample, as the table that we have created. So that's all from me. Thank you.